All right, so here we are in section 2.4. If you're wondering what happened to section 2.3, we actually don't cover 2.3, so we're skipping it and going straight to 2.4, where we're going to take a look at multiplication of matrices. All right. Now, in multiplication of matrices, there are two types. So there are two types. There's a P in there. That just looked terrible. Two types of multiplication. I'll cram it on the end. There's going to be scalar multiplication, scalar matrix multiplication, and then true matrix multiplication. Scalar multiplication is the first type we'll look at, and then we'll take a look at matrix multiplication. At the end, we'll take a look at what an application of this would look like. All right, scalar multiplication of matrices. Scalar multiplication matrix says take a scalar k, so that just means a number, and multiply by a matrix x, and you'll get the matrix k times x, where every element is just the original matrix x multiplied by k. So here's a really straightforward example. I'm taking the scalar 3, that's the k from the definition, multiplied by the matrix x, and so then 3 times 4 gives me 12. 3 times 6 gives me 18, 3 times 5 gives me 15, and 3 times -3 is -9. Right? Scalar multiplication is exactly as easy as you want it to be. It's just simply taking that scalar and distributing it into the matrix by multiplying by every single element in there. Let's take a look at an example. So here I have a matrix A, and I want to find out 2 times A. So I'm multiplying the scalar 2 times the matrix 1, 3, -1, 5. And when I do that multiplication, I'm going to get the matrix 2, 6, -2, 10. And there's my matrix 2A. It's exactly what you want it to be. Right? Here's the matrix B. What is -3 times B? Well, that's going to be -3 multiplied by the matrix -2, 4, 7, 9, and so that's going to give us -2 times -3 is 6, -12, -21, -27, and that is the matrix -3b. Right. Scalar multiplication is just that straightforward. Right? Here's the one. True matrix multiplication. This is the fun one, where we're going to do a matrix times a matrix. And this is the definition. And every time I teach this course, I always think that definition's no good, because it doesn't make any sense until you've done it. So let me take a look at an example down here, and then we'll work backwards from this. Here I have two matrices, and my job is to find the product if possible. And that statement right there always makes me pause for a second, because that means it might not be possible. So how is multiplication not possible? Well, let's take a look at the rules. The first matrix here on the left is a 2 by 2 matrix. The matrix on the right is a 2 by 1 matrix. And if my job is to multiply these two matrices together, the first thing that has to be true is these must match. If those two numbers aren't the same, that is, if the number of columns of the first matrix is not equal to the number of rows in the second matrix, then you cannot multiply them together. And then these two numbers, they tell me the size or the dimension of the product. So I know that when I multiply these two matrices together, the answer that I get is going to be a 2 by 1 matrix. All right, so I'm going to go ahead and do this multiplication. So I'm going to take the first row of this matrix and multiply it by that first column. And the way I do that is I take the first entry times the first entry plus the second entry times the second entry. Right. And then I'll move to the second row times that column. And so it'll be the first entry times the first entry plus the second entry times the second entry. And now I'll go ahead and do this math right here and this math right here and see what we get. So let's see. 2 times 3 is 6, so that's going to be a 6. Negative 1 times negative 2 is positive 2, and 6 plus 2 gives me an 8. 5 times 3 is 15. 8 times a negative 2 is negative 16. When I add those together, we get a negative 1. So multiplying matrices together. I take the row from the first column, multiply it by the column from the second matrix. I said row from the first column, didn't I? The row from the first matrix, and multiply it by the column in the second matrix, entry times entry plus entry times entry plus entry times entry, and just work my way through it. And then repeat and repeat and repeat. All right, let's try it again. How big is this first matrix? Well, this first matrix is a 2 rows by 3 column matrix. My second matrix is a 3 row by 1 column matrix, and I want to multiply these two things together. My inside numbers match, so that means I can do it. Three columns in the first matrix, 3 rows in the second matrix. And my outside numbers tell me that the answer, the product, is going to be a 2 by 1 matrix. So 2 rows, 1 column. All right, so I'll start by taking that first row and multiplying it by that column. So that'll be 2 times 5 plus negative 1 times 10 plus 7 times 2. And then I'll do the second row times that first column. So that'll be negative 3 times 5 plus 0 times 10 plus negative 4 times 2. Now I'll go ahead and do that math that's hiding in there. 2 times 5 is 10, negative 1, negative 10 there, and 14. So I think that's going to add up to 14. That's negative 15, that's 0, and that's negative 8, so negative 23. And so the product of the matrix 2, negative 1, 7, negative 3, 0, 4, and the matrix 5, 10, 2 is the matrix 14, 23. Now, I know what you're thinking. As much fun as this is this the only way to do these? Is by hand the only technique? And the reality is, no, I can definitely use my calculator for this, because matrices work on a calculator. So let me go ahead and get this set up. Now that I got it set up, what I'd like to do is I'd like to go back and redo each of these problems and see if we get the same answers doing it on the calculator as we did by hand. So I'll do this one first. All right. So first things first, I need to put those two matrices into the calculator to see if I can get the same answer. And I erased a little too much, so let me bring that back and put that equal sign in there. Okay. All right, so go to my matrix menu. I'm going to edit. That matrix is a 2 by 2 matrix. The entries are 2, negative 1, 5, and 8. So this matrix is in matrix A. Then I'll quit out of there, go back to matrix, down to matrix B, and then edit it. And it is a 2 by 1 matrix, 2 rows, 1 column. The entries are 3 and a negative 2. Okay. Then I'll quit out of there, and then I'll go back to matrix and grab the name of matrix A and multiply that by matrix B. 8, negative 1. Same answer we got by hand. Right. And it should be, because we did it right. Right? Now, remember when we were talking about these and I said since the first one's a 2 by 2 and the second one's a 2 by 1, we can multiply them together? What if we change the order? What if we tried to take the 2 by 1 times the 2 by 2? Well, these don't match, so it shouldn't multiply. So how would that look on the calculator? Well, if I grab B and try to multiply it by A, there's what it tells me. It tells me dim mismatch. Dim here is short for dimension. Dimension means the size of the matrix, and so there's a dim mismatch. There's a dimension mismatch. It can't do it because they're the wrong size. Right? So if you see a dimension mismatch error, a dim mismatch error, that just basically is the calculator trying to tell you you did something wrong. You can't do this matrix multiply. All right, so just to be sure I know how to do this, I'm going to do this one as well. So I'm going to go back to matrix, over to edit, editing matrix A. It is now a 2 by 3 matrix. The entries are 2, -1, 7, -3, 0, -4. And I'll quit, go back to matrix, over to edit, and then down to matrix B. And now I want to put in a 3 by 1 matrix, 5, 10, 2. So then quit out of there. And I want to take matrix A and multiply it by matrix B. And I get 14, -23. Same as we got by hand. Now for some of these matrices, if they're small enough, doing it by hand isn't necessarily that much slower or less convenient than the calculator. But when matrices get big, or if the entries in the matrix get ugly, then the calculator is definitely a huge advantage. Right? For example, what if we had something like this? The four departments of Spangler Enterprises need to order the following amounts of the same products. And so I have rows in the first matrix that represent the departments at the company, departments 1 through 4. And I have columns that represent what they're ordering: the paper, the tape, the binders, the memo pads, and the pens. So while this is a matrix that I'm sitting here staring at, when I think about what this really means is it's an encoded bunch of numbers that actually mean something. I can look at this 5 right here and I can say that 5 means that Department 3 needs 5, I don't know, tape comes in, is it rolls of tape? And so I can read the matrix for what it actually says. So let me get rid of all that because I'll need to go back and use this matrix. So it's actually just using the matrix for something more than just saying, here's some silly numbers. I'm actually putting things in it to make sense. Same thing down here. I've got a matrix, right? And they want us to use matrix multiplication to get a matrix showing the comparative cost for each department. Okay. All right, when I think of this first matrix, when I see this matrix here, how big is that matrix? Well, it has 1, 2, 3, 4, 1, 2, 3, 4, 5. So this is a 4 by 5 matrix. Okay? When I look at this matrix right here, this is a 1, 2, 3, 4, 5 by 2 matrix. So can I multiply, and let's just keep things simple, I'll call this one A and this one B. Can I multiply A times B? Well, if I'm multiplying A times B, that means I'm taking a 4 by 5 and trying to multiply it by a 5 by 2. These numbers match, so I can do it. And then my product matrix will be a 4 by 2 matrix. Okay. Now, beyond simply saying, can you do it, should we do it? Okay. Well, let's take a look at what it would mean. So let's just say I did multiply matrix A times matrix B. Okay. Let's say I took matrix A times matrix B. I know that my answer is going to be a 4 by 2 matrix, 4 rows, 2 columns. So this first entry is going to be the first row multiplied by the first column. So that's going to be Department 1, 10 units of paper multiplied by $2 per unit of paper plus 4 rolls of tape times $1 per roll of tape plus 3 binders at $4 a binder plus 5 memo pads at $3 a memo pad plus 6 pens at $1 a pen. And so when I do that multiplication, 10 reams of paper at $2 a ream, that's the total amount of money I'm going to spend on paper. And when I do 4 rolls of tape at $1 a roll, that's the total amount of money I'm going to spend on tape. And 3 times 4 is the total amount of money I'll spend on binders. And 5 times 3 is the money I'll spend on memo pads. And 6 times 1 is the money I'll spend on pens. And when I add them all together, that's going to give me the total for Department 1 if I buy everything from supplier A. And then when I find that first row second column entry, I'll be taking that first row and multiplying it by that second column. So I'm going to find over there, I'll find the total for Department 1 if they buy from supplier B, and so on and so forth throughout this whole matrix. So not only can I put things in matrices, and not only can I multiply things together, but the answers can mean something. So I'm going to go ahead and do this, but I'm not going to do this one by hand because a 4 by 2 matrix, the answer to this would be a 4 by 2 matrix. That's 8 things, and I don't feel like doing that. So I'm going to use my calculator. So I'm going to go to my matrix. I'm going to go over to edit. I'm going to edit matrix A. And we said the matrix A was a 4 by 5 matrix. And the entries were 10, 4, 3, 5, 6, second row 7, 2, 2, 3, 8, and third row is 4, 5, 1, 0, 10, and the last row is 0, 3, 4, 5, 5. Quit. Go back to matrix, over to edit, down to matrix B to put in the second one. The second one we said was how big is that? It's a 5 by 2 matrix. First row is 2, 3. Second row is 1, 1. Third row is 4, 3. Fourth row is 3, 3. And the fifth row is 1, 2. Okay. And then I'll quit. And then I'll do matrix A times matrix B. And I get 5770, 4154, 2740, and 3940. Now, if I want to put labels on these, when I multiplied these together, my answer was the 4 by 2. My answer was this 4 and that 2. So I'm going to use the labels or the units from that 4 and from that 2. Well, that 4 was these labels right here. So this is Department 1, this is Department 2, Department 3, Department 4, and then the labels on the 2 were these. So supplier A and supplier B. And so then when I look at this matrix, I can look at this number right here, 54, and say, what does 54 mean? Well, that means that if we order Department 2 supplies from supplier B, it'll cost us $54. Or if I order Department 3s from supplier A, it'll cost me $27. So matrix multiplication. That brings us to the end of section 2.4. I'm going to end it here, and we'll come back and do matrix inverses in section 2.5.